Hey folks, today I'm going to share with you something I've been working on lately. It's a really big revamp of a TI-99 synth program I put together a while back called Still TI, parodying Portal's Still Alive in honor of the TI-99. I'd put that tune together using the Terminal Emulator 2 cart, and consequently all the coding and pattern generation from start to finish was done in TI-99 4A Console Basic, with the final program just feeding Allophone patterns to the cart's Allophone I/O device. But lately I've given the program a massive glow up using a combination of more powerful tools, and I'd like to share the result with you as I think it's a lot more interesting than the original was. This new program is done in Extended Basic using 80-column graphics via Harry Wilhelm's T80XB, and uses speech routines from TI's text-to-speech disk. So I'd like to think of it as a nice little tech demo for T80XB graphics, as well as for custom synth using modern Extended Basic tools. I'm going to cut to the chase and show you the result, but stay tuned because I've got a lot to say about what went into making this happen when that's done.
This was a triumph. I'm making up no fear. Huge success. It's hard to overstate my satisfaction. Solid state software. Developed my Texas instruments. With sprite-based graphics, sound and synth in an aluminum case. So there's no sense trying over every weight state. We're just firing out the issues on the 99.8 and not owning next time. You lost and overload and run. For the people who are still TI. I'm not even angry. I'm being so sincere right now. Even though you left me for a PC. And it sold me on eBay. And it shipped every piece to God knows where. As they sold it hurt because I was so happy for you. Now these Mode 1 graphics make a beautiful line to the music on the SM76489. So I'm 99% glad for all the time we spent, and for the people who are still TI. Go ahead and leave me. I think I prefer to stay right here. Maybe you'll find someone else to help you. Maybe a tree. That was a joke. Haha, fat chance. Anyway, this speech is great. It's so believably moist. Look at me still talking, I've not coded too long. I've got 99 problems, but with you ain't long. There are experiments to do on someone better than you. On the people who are still TI. And believe me, I am still TI. I'm doing science and I'm still TI. I feel fantastic and I'm still TI. While you're dying, I'll be still TI. And when you're dead, I will be still TI. Still TI. Still TI.
So there you have it, the nonsensical marriage of speech synth and TI-99 80-column graphics that I never knew I needed in my life. If you're interested in running this yourself, a link is in the description. But to clarify what's happening here for those less familiar with the technology, TI's text-to-speech engine uses an intermediate encoding in which speech is stored as a sequence of byte values, and each of those values signifies one of two things. Either a speech pattern, like say the vowel oo or e, or a command to specify the dynamics of speech, like a command to change the current pitch or phrase contour, or to mark a stress point. Here's what TI's Allophone speech looks like up close in its raw form. In this early phase of the program I'd been working on, incidentally, I had the speech strings stored in the plain in the program text, so that's how you see it here. And you can see a pretty typical structure for a single syllable, beginning with the value 252 to prompt to accept a new pitch value, followed by that new pitch value of 37, or roughly 111 Hz, then two phonetic elements, which are an I diphthong and a word final M, respectively. So that gives us in only 4 bytes the word I'm sung at 111 Hz, making it possible, even with whatever additional phrase dynamics outside that, to encode entire songs in a space small enough to easily fit in the TI-99 4A's memory, or on a legacy floppy. And even while sharing space with a pretty massive interpretation framework. Meanwhile, that interpretation framework does the difficult job of turning these patterns into LPC-encoded speech. I've mentioned in previous videos the limitation of this method is it's very difficult to control the pace or timing of speech. While the LPC pattern itself could be stretched out arbitrarily in principle, the Allophone just produces a predetermined chunk of LPC speech data of predetermined length, with certain controls for modifying its dynamics. So from Allophone data alone, we can't really know how much LPC data of what duration we're going to get, and how long it's going to take to get processed. And further increasing the mystery, there's only a moderate correlation between the time duration of the LPC speech and its data payload. As you can see here, the data content of LPC speech frames varies hugely. So even if we did know one of those things, say the volume of LPC speech data we were getting, we wouldn't actually know its duration without further analysis. But don't get me wrong, Allophone speech is pretty cool, and it's a pretty functional and efficient tool. And the Terminal Emulator 2 cart makes it available directly from TI Basic. Still, I definitely wanted to do more than that, especially after some helpful folks pointed out further options. Particularly, I wanted to work with Allophone speech in Extended Basic, ideally using modern supporting assembly routines. And the tool to make that happen was TI's text-to-speech disk. That disk contains 3 key assembly language object files, but one of them, xlat, is just concerned with text-to-Allophone pattern translation, which I don't need since I'm composing my own patterns. I'm just interested in playing the Allophone patterns I've created manually. So that one I can ignore. The other 2 I'm interested in are setup and speak, both of which I'll need to play my Allophone speech in Extended Basic. Load these files, which does take a while, and run the setup routine, pointing it to the database included on the speech disk, and we can use the speak routine to play Allophone speech. So this gets me as far as using Allophone speech in Extended Basic. But as I'd mentioned, I really prefer to use additional modern support routines as well if I can. And there is one solution that allows that to happen here. Harry Wilhelm's HM Loader, provided with his The Missing Link collection of Extended Basic bitmap graphics-oriented routines, allows for some assembly routines to be successfully loaded into high memory, which is to say the TI-99 4A's 32K memory expansion. In this case, while the speak routine will not function correctly from high memory in my experience, the setup file will, and loading setup into high memory and executing it there leaves more space in low memory, which is to say the TI-99 4A's lower 8K, in which to load additional supporting routines. And if I'm doing a lot of speech, I'm probably going to want to print a lot of text too. So T80XB, likewise by Harry Wilhelm, was a great fit with its support for 80-column graphics in Extended Basic. More space, more text. And since I do have an F18A video processor, I've got appropriate hardware to allow for those 80-column graphics. There lies the rub where portability goes, though. The upshot of this choice of supporting routines is that the program has fairly high requirements, namely 32K disk speech synth and 80-column support on original hardware, or otherwise all of those things correctly emulated. The only emulator I know runs it satisfactorily at this point is JS99er, but F18A emulation must be enabled there. It might work correctly with MAME given an appropriate 80-column configuration, but I haven't tried to set one up yet. I've got to say part of the fun of working with 80-column mode was the insanity of working with 80-column graphics, wherein pixel aspect ratio is very odd, and tiles are displayed as 6 by 8 with the last two columns in a pattern unused. So the actual patterns that go into the image on the left here are the patterns on the right there, shown with 8 by 8 tiles and a more typical pixel aspect ratio. GIMP helped a lot in working with this situation since it allows for design using non-square pixel aspect ratio and distinct horizontal and vertical grid intervals, so I was able to do the art on a 6 by 8 grid where pixels are much taller than they are wide. The musical accompaniment from the PSG was necessarily a little limited, given the speech routine more or less completely monopolizes the system. For example, if you set a sprite in motion and call the speak routine, that sprite is just going to stop in its tracks. That's not true, incidentally, for pre-generated LPC speech patterns used via call say,
Hello.
but it is for Allophone speech via the speech disk. In any case, you can always sustain a chord and then play some actual music in between the speech, so that's what I did. So I hope you enjoyed this creation of mine. If you've got the hardware to use it, or you're happy to use it via emulation, I highly recommend checking out T80XB. For primarily text-driven contexts, it's a terrific weapon to have in the extended basic programmer's arsenal. And if you don't need all 80 of those columns, T40XB, its sibling, gives you 40 instead. And I did start this program out on 40 columns myself before I got greedy. So thanks to Harry Wilhelm for both of those tools. And have fun, folks. As always, party like it's TI-99.